Hello, welcome back to the channel. So now let's continue our previous videos where we were calculating some indefinite and definite integrals by identifying the pattern and looking at the chart and then evaluating those definite or indefinite integrals using the chart. So in the last videos we covered definite integrals. In this video we'll be covering indefinite integrals, but the approach, as you know, will always be the same. If you have to calculate a definite integral, it will just be an extension to calculating the indefinite integral first and then using those endpoints to calculate the definite integral, which you already know from the last videos. So if you have not watched my previous videos, I would highly suggest you to first watch those videos in order to get the full context of this video. So let's now evaluate this expression. So this expression is 1 upon 1 plus 25x square, and we have to calculate the indefinite integral of it because we don't have any endpoints. So remember, when you're calculating the indefinite integral, always include the constant of integration at the end. So that is the first important point that we will consider in this video while solving the question. The next trick in order to calculate such type of questions is basically to identify the pattern first and then see from the chart. You won't probably have a chart, but if you keep on practicing more and more, you'll probably remember all these famous indefinite integrals. And based on the pattern and the knowledge of the chart, identify the best approach that you can follow in order to solve these type of indefinite integrals. So in this type of question, we have to calculate the integral of 1 upon 1 plus 25x square, right? And if we look over the chart, let's identify the pattern which looks similar to this type of indefinite integral. And we can clearly notice in this case that 1 upon 1 plus x square seems very similar to this expression, right? So I just want to convert this expression into a similar looking expression like this, where I have something like 1 upon 1 plus something square. So let's try to approach this problem in this way. And if we have to recap again, the first thing is to the pattern, identify the pattern inside your indefinite integral and look for what would be the best approach in order to follow or in order to evaluate your indefinite integral. So now we have found that it's much easier for us to convert our this expression into similar looking expression like this. So now let's try doing that. Our basic idea is to get something which resembles 1 upon 1 plus something square, right? So let's do that. I'll write the integral again. So the integral is 1 upon 1 plus 25x square, and I want this term to be a square term, right? So I need to use some combination for which I can have this term as a squared term. And we can easily see in this question that I can write 25x square as 5x to the whole square, right? Such that it would resemble something like 1 upon 1 plus something square. So we can do this. We can write this as 1 upon 1 plus 5x to the whole square, right? And dx again. Now we have a similar looking expression like this. Instead of x in this case, we have 5x over here, and we'll adjust the constant afterwards when we calculate the final answer, right? So this was the first thing that we would do. We would identify the pattern and then change our indefinite integral according to the pattern. So now since we have changed it according to the pattern, we know that if it's 1 upon 1 plus x square, it's arctan x plus c. So for solving this, since we replaced our x with 5x, the first guess would basically be this one, right? So the first guess, this is a guess. So the first guess after this would be something like arctan 5x plus c, right? This would be our first guess in order to solve these definite integral, right? But you're missing one important thing into it. The important thing about writing integrals that we also covered in differentiation as well is that we are neglecting one important rule, which is known as the chain rule. So if I differentiate this expression, since we know that integration is the opposite of differentiation, if I differentiate this one, I should get this function, right? Based on the fundamental theorem of calculus. So let's try differentiating this function and see what we are missing in this initial guess that doesn't make it a correct answer. So let's go over this problem. If we differentiate this one, we will get 1 upon 1 plus 5x square, right? And we'll also, because of the chain rule, we'll take the derivative of everything which is inside that function as well. So if we take the derivative of 5x, the final answer in this case would be 1 upon 1 plus 5x square times 5, right? And that is the 5 we were missing in our initial guess. So in order to do that, since we have an extra 5 over here, if I differentiate this one, I have an extra 5 over here. So in order to get the final answer, I'll have to divide this expression by 5, so that when I'm differentiating this expression, which has a denominator 5, this 5 will get cancelled out to the initial denominator we'll have. And we'll see this part in the next approach we'll do. So now, based on differentiating this, we realize that we are missing a 5 over here, which can be adjusted by taking 5 as in the denominator of this expression. So now let's start with the next guess. The next guess would be 1 by 5 arctan 5x plus c, right? And don't forget the constant of integration because it will always be there since it's an indefinite integral. Let's differentiate this expression and see if we can get our original expression. So if we differentiate this one, if we differentiate this expression, we would get 1 by 5 would remain the same, and this would become 1 upon 1 plus 5x square, and the 5x, because of the chain rule, will have to take the derivative of 5x as well. And the derivative of the constant of integration would be 0, so we don't care about that in this case. And now if we try to evaluate this expression, it would be 1 by 5 times 1 upon 1 plus 5x square. D by dx of 5x would become 5, and now this 5 will get cancelled out to this, and if we evaluate this expression, it would become 1 upon 1 plus 25x square, which is the same as this expression for which we were calculating the indefinite integral for. So that is the thing that you have to consider whenever you're taking indefinite integrals. It's always good to check when you're calculating indefinite integrals because it's very easy as well. You can just differentiate your initial guess and check if it matches with the starting expression that you were calculating an indefinite integral for, right? So that is the important point we covered in this video. But if you also want to get a general understanding about these type of questions, these type of patterns, in most of the cases when you have a constant with a function, as in this case, the original expression was supposed to be x, but it was 5x. So whatever constant you'll have in front of x or the function, you just take the reciprocal of that constant and attach it to this type of pattern. And that is only because of the chain rule, in order to consider the chain rule. So in this case, since you were calculating this, it was 1 upon 1 plus 5x to the whole square. And the basic pattern says that whenever you have these type of questions, you will write it as arctan x plus c. So we wrote it as arctan 5x plus c. But in order to adjust for the chain rule as well, since we had 5x instead of x, whatever constant we had, we took the reciprocal of that constant and attached it to the final answer. And that is why our final answer was this. And we also checked this result by differentiating this expression, and we got the original expression, which confirmed that we were on the right track. So these are some important points that you can definitely use in order to solve indefinite integrals. Don't worry, we'll do more questions on these patterns as well, and you'll get used to adjusting these constants with your functions as well. So don't worry about it for right now. We'll cover more questions in detail in the next videos as well. So that's it for this video. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.